Okay, so in our study of system of equations, we've come to a word problem. Okay? And in this word problem, we have that all of the 5th grade teachers and students from Covington went on a field trip to an art museum. The tickets were $8 for teachers and $3.50 for students. And the whole group spent $30 that day. Okay? Now, that's the first scenario. Now the question is, how do I know that I've got a system of equation word problem? Because that's the hardest part, is evaluating, is this a system of equation word problem? Well, they provide me with a single scenario here, right? And then below in the next sentence, they provide me with another scenario. So when you have two different scenarios, you know it's a system of equation word problem. So let's make an equation for the first scenario. Let's make an equation for this scenario up here. I'm going to make my equation in red. Tickets were $8 each for teachers. Now, I need to define a variable for teachers, and I need to define a different variable for students. It doesn't matter the variable, but generally we use what? X for the teachers, yeah, X, and then Y for the students. Okay, and the only reason I chose X for the teachers is because they came first and X comes first in the alphabet. So now let's make an equation. Tickets were $8 for each teacher plus $3.50 for each student, and the total they spent was $30. Okay? And then in the second scenario, we say they went on a second trip, same number of students went, and they spent $16 on teachers and $12.50 on students, and the total that day they spent was $82. And so the question is, how many teachers went and how many students went? Right? And so you see you have a system of equations right here, and you have three different ways to solve it. You could solve it by substitution, you could solve it by elimination, or you could do it by graphing. Now, it appears to me elimination would be easiest because if I multiply the top equation by what? Negative 2, I'll immediately eliminate the x's, won't I? So let's go ahead and do that. Let's multiply the entire top by negative 2. Now when I multiply that top by negative 2, my resulting equation is negative 2 times 8x is negative 16x. Negative 2 times 3.5y is negative what? 7y. And negative 2 times 30 is negative 60. Remember, you can multiply the entire top by a number. As long as you multiply it by that number on everything, you don't change the outcome or the answer. Now, let's deal with these two equations from now on. I'm going to add them up. 16x plus negative 16x is what? 0x. And that's why it's called elimination. We essentially eliminated the x's, right? 12.5y plus negative 7y is what? 5.5y, and that equals 82 plus negative 60, which is 22. Okay, now solving for y, which is the number of students who participated, is easy. We'll just divide by 5.5 on both sides. And so the number of students who participated, y, is 22 divided by 5.5, which is 4 even. So 4 students went on the trip. And it makes sense that it's a whole number because you can't have like a half a student go, right? Okay. Now, we know 4 students went. Okay, but we don't know how many teachers went. And we know that y represents the number of students, so why don't we plug 4 in for y in this equation or this equation or this equation? You could plug it for any y, right? I'm going to use the top equation because it seems to have the smallest numbers to deal with. So for y, right here where y is, I'm going to plug 4 in. So I'm going to rewrite this as 8x plus 3.5 times 4 equals 30. And so right here where the y was, I put a 4, didn't I? Now what is 3.5 times 4? So I've got 8x plus 14 equals 30. And then I'll subtract 14 on both sides. And I have 8x equals 16. And it's clear that when I divide 8 on both sides, my x is going to be what? 2. So what we're saying is 2 teachers and 4 students went on the field trip.